Hello my fellow maniacs, today I'm here to explain to you about particle theory in the category of evaporation. So basically evaporation is a liquid turning into a gas like water boiling, then becoming steam. So now I should basically show you what evaporation looks like. So I got a thing called a bloomer vial here, I will throw it over there. As you can see, when I threw the vial, the liquid quickly evaporated and attracted a lot of zombies. So, thank you for watching, and next slide. Hello my fellow maniacs, today I'm here to talk to you about more of particle theory. Just this time I am talking about condensation. Condensation is when gas goes from a gas to a liquid. A cloud is basically condensation. I have a mechanical one to show you today. So I've made this contraption here, so I'm just gonna flip the switch, which this is supposed to be a cloud, but I couldn't really find one, even though those ones won't dispense rain. But I don't want to drag this out. So, as you can see, the gas has gone from a gas to a liquid, and the water being the liquid, in this case, the cloud being the gas. Alright, next slide. Hello my fellow maniacs, and today I'm still here with more particle theory for states of matter. Today I'm here with freezing and what it is. Freezing is when a liquid goes from a liquid to a solid, usually in cold circumstances. So this is what basically happens. I have my little cold mist producer, and bang, block of ice. As you can see, the water has now become a block of ice when I applied the cold to it. So that is the basics of freezing. And next slide. Hello my fellow maniacs. Today I'm here to talk to you about melting in the particle theory. Melting is when a solid goes from a solid to a liquid, which is usually triggered by high temperatures. An example could be like this. So flint and steel, and as you can see, the ice is melting around it. As you can see, the ice, aka the solid, is melting into water, the liquid, under the heat of the fire. So that is melting onto the last side of Patchman. Boop. Hello my fellow maniacs, I'm here today to talk to you about sublimation in the final part of part 1 in the particle theory. So sublimation is a solid going from solid to a gas, like dry ice. Sadly, I have no dry ice, so instead I will try to replicate it with this bucket of lava and this tower of ice. So even though you cannot see it, I will explain what is happening in the tower. As you can see, the lava starts encasing the tower. Inside the ice, the solid is slowly becoming a gas, the lava. So that is sublimation, and the end of part 1, but not the end of particle theory on part 2. Break it down. Hello my fellow maniacs, and welcome to part 2 of particle theory. Today I'm here with temperature of particles, each form of particles. Yes, each form of matter, liquid, solid, and gas has a temperature. A solid has a low because particles are more compact. A liquid has a high temperature because the particles are more spread out. A gas has a high temperature because particles are all over the place, which is basically oxygen. Alright, well, that is it, and next slide for temperature of particles. Hello my fellow maniacs, today I'm here with more particle theory. I'm going to be discussing the topic of volume in particles. For the parts of matter. A solid has a definite volume because of its shape which is also definite. A liquid's volume can change due to its shape, which changes depending on its container. A gas's volume is indefinite because it is everywhere. That is it, and guess what? Hello my fellow maniacs, today I'm here with more particle theory. This time I'm going to be talking about the movement of particles. A solid's particles move at a slow pace because the particles are more compact together. A liquid's particles move fast because it's more spread out. Gas particles are super fast because it's everywhere, so it's able to bounce around more. Well, onto the final slide at Patty. Hello my fellow maniacs, and today I'm here with more particle theory today. With this time about space in between particles. For a solid, there is almost no space because of its shape. A liquid is a little better in space between because it is a little bit less compact. Gas has a lot of space because it is everywhere, which I've said a lot during part 2. That is the end of part 1, but part 3 is going to be the last part on the next part. Alright. Hello my fellow maniacs, today I'm here with energy levels of particles. For each state of matter it has an energy level. A solid has a low energy level for the reason that the particles in a solid are more compact and don't move as much. A liquid has a high energy level because the particles are more spread out and can move faster. A gas has high energy level because the particles are everywhere so they can bounce around more. So that is the basics of energy levels of the particles. Next slide. Hello my fellow maniacs. Today I'm here with shapes of particles. Each state of matter has a shape of sorts. A solid can never change, therefore it is a definite shape. A liquid takes the shape of the container it is in. A gas is everywhere, so it's basically the same as liquid in the way that it takes the space up of the container. There you have, and we are now on to our next slide. Hello my fellow maniacs, and welcome to the beginning of the end of particle theory. Today I'm here to basically wrap up and tell you what particle theory is. The other parts that we have done are just bits and pieces of particle theory. I'm going to now tell you what it actually is. So particle theory is the theory that everything has little particles. That means that we have particles bouncing around in our bodies, your pets, even the air you breathe has particles in it. So that basically wraps up particle theory. That's basically all that particle theory is what I just said. Yes. If you're watching from YouTube, don't forget to leave a like, subscribe, and favorite the video. Alright, I will see you next time, or whatever I make. It is gonna drag on. Peace out. Burp.